Hello 108 students, Mr. McHugh back with you here. Welcome to section 7.5. We are going to go ahead and deal with some application problems with rational expressions in them, rational expression equations, and page 1, of course, we're going to tackle that first. Okay, so best way to work on some of these problems is have your book with you and look on page 396. I like these application problems, and I was teaching out at Micron a couple years. I first taught 108 a couple falls ago. I had some engineers out there. Well, I guess they weren't engineers. They wouldn't have taken 108, but some students from Micron who worked with this example, find the values of lenses, and so from a mathematical viewpoint, we're given this equation 1 over f equals 1 over p plus 1 over q. And I just want you to look in the book and see the picture. They have an apple, and they tell you p is the distance from the object to the lens, r is the focal length, and q is the distance from the lens to the image. Now, what I do not have on my class notes is that visual picture image, and if you look at it, it'll help you see that when your lenses are working, your cameras, this formula is used. Now, I wish we had more time and I could explain more why it's in this form, but we're going to go ahead and tackle. The first example is, what if you're given values for f and p? Could we find q? Okay. So looking at the example here, they are going to tell us f equals 10. This is given to us, and p is a value of 20. Okay, so that's given. Now, could we find q? Okay, so you look at this and you substitute it in there, and you're like, oh my word, everything's in the denominators. Don't care for fractions, rational expressions. What can I do? Answer, hopefully you remember. Determine the LCD and multiply it across the board, across the equation or every term. And so you have 10 and 20 and q. Between 10 and 20, the LCD would be 20 because 10 goes into 20, and the q. So every term got multiplied by 20q. Okay, there's where we did there. You multiplied by the 20q, and the beauty of this is it's going to, quote, clear out the fraction because 10 goes into 20 two times, leaving you 2q. Notice the fraction's gone. 20 goes into itself once. 1 times 1 is 1q, and q divided by q equals 1, so that cancels out because it's 1 times 20, and you get 20. So all of a sudden, this idea of multiplying by the LCD now produces, a fairly straightforward algebra equation that you combine like terms. I would move the 1q back over to the left, so 2q minus 1q is 1q equals 20, and there's your answer. Okay, so those plug and chug problems again aren't too bad. Remember, the key thing is determine the LCD and multiply it. Okay, now remember that concept, because in this chapter you notice every once in a while we keep taking formulas and we keep isolating one of the variables. So example 2, we're going to do the same thing, and that's my black lab barking. Hopefully she'll come. Well, it's my neighbor dog and my black lab. Hopefully they'll be quiet. So in this example 2, they tell you, given this equation for lenses, determine what p is. Can you isolate it? Okay, now again, I think of those Micron guys here. They might take in this equation. This might be something they would go through if they were given f and q all the time. If they could have the equation transform so it's isolated into p, it would be easier for them to do. Maybe they would use that in programming at an Excel spreadsheet. Okay, maybe they got to take a lot of readings and they want to know, if I want to find p given f and q, what would it be equal to? Okay, so our challenge is, how do you isolate that p variable? Key thing, determine the LCD and multiply it. So here we go. We got f, p, and q. So that will be the LCD. Every denominator has to be a factor in the LCD. So I took FPQ and I multiplied it in front of every term of the equation, or across the board, as I like to say. Okay, that clears out the fraction. If you get the correct LCD, it always works. F in the denominator cancels out, leaving you with FQ. Oh, PQ. I'm sorry, PQ. Okay. Now over here you've got P and P cancel out, and you're left with FQ. And finally, Q and Q cancel out, and you're left with FP. Okay, now you're like, fine. Here, let me make sure. I'm going to switch my colors here a little bit. Your goal here is to isolate what variable? You got to say this over and over again, the P variable. Okay, what variable are we going to isolate? P. Okay, now, problem is you need to have them both on the same side. That would be my next step. So I would think about moving that FP over, squeezing it in there. PQ minus FP are different terms, so you leave it alone. If these were numbers, then you would subtract it, but you can't do that when you just have all algebraic variables. So PQ minus FP equals FQ. Okay, now you're doing good. You're looking at it, and again, I'm going to go in green mode. What are you solving for? Isolating the P variable. You say, great, it's on the left-hand side, but it's in two different terms. What am I supposed to do? And then hopefully you have a moment of lightning bolt striking you. And here's where I'm happy that you look at the two terms PQ and FP, and you realize there's multiplication going on, and therefore P would be what in each of these? Okay, think about it for a second. I'm hoping you're going to say factor. And as soon as you realize it's a factor, you pull it out as a GCF. That's the key step here. P is in both of them. You pull it out as a GCF. So it's P times the quantity Q minus F. Okay, now that's the step right there. So when you practice these problems, make sure you see that moment of when you pull out the GCF, which is the variable you isolate. Now you got something to work with, because the question now becomes, can I isolate the P variable? And I go, it's P times the quantity Q minus F. So if I divide by Q minus F on both sides, Q minus F divided by Q minus F cancel out. I'm left with P. I finally isolated it, and P equals F times Q divided by Q minus F. Okay, that's a little tricky. It's good practice for you. Definitely good practice. It helps you get your algebra toolbox, your algebra properties, and balancing the equations to isolate your variables down. Okay, Mr. McHugh here. Go ahead and sign off on page 1. Good job, everybody. I will see you for page 2, and I'll talk to you later. Bye.